All right, in the past few lessons, we've been practicing creating these sample date time indexes that are filled with pandas timestamps. And in this lesson, I'll introduce a method that allows us to generate date ranges or date time indexes automatically on the fly. It's a pretty robust method, and it'll actually require 3 lessons in order for me to dive into all the different combinations of parameters that we can use, and it's called the date range method. So it's called directly on the pandas library. So let's begin by writing PD followed by this method right here called date range. There is an underscore there in the middle, and I'm going to add those parentheses because it is a method. And let's press Shift Tab to take a look at our available parameters. So you can see the first 3 parameters here are start, end, and periods. And in order for this function to run, 2 of those 3 parameters are required. So you can have start and end, you could have end and periods, or you can have periods and start. And we're going to go through all 3 combinations throughout these 3 lessons. But just keep in mind, by itself, if I try to execute it like this, we're going to get an error because at least 2 of those, actually exactly 2 of those parameters are required in order for this method to work. So how does it work? It basically accepts some kind of combination of parameters, and it generates a datetime index for us. So let's go with the simplest example here, which is using the start parameter and the end parameter. So I'm going to provide arguments to the start parameter, and let's say I start at January 1st, 2016. And let's say I'm going to end 10 days later, 2016, 01, 10. So January 10th, 2016. And I also want you to pay attention to this freq parameter right here, which is short for frequency. And the default argument here is set to a capital D, which means days. And I'm actually going to write this parameter out, just so we have a reminder. So what this is going to do is it's going to generate a datetime index that starts at January 1st and proceeds all the way to January 10th. And the interval between how it's going to do that is going to be 1 day. So let's take a look here. So here, as you can see, it's generated a datetime index. We have 10 days here, and it started at our start date, and it's proceeded in increments of 1 day. So here we've moved from January 1st to January 2nd, and it's done that until it reaches our end date, which is January 10th. So you can see it's proceeded at a frequency of 1 day. Now, the advantage here is that we don't need to, create our own fictional list here of dates and kind of feed it in as an argument to a datetime index or a toDateTime method within pandas. This thing will automatically generate this datetime index and it's ready to go. So for example, if I store this operation in a variable called times, what I can see here is times is in fact a datetime index, and if I take a look at times again and I extract the very first item, which I can do by using bracket syntax because it is essentially an array or a list, there's my very first item within my datetime index. You can see here that it is a timestamp, and if I load that into my Python type function, I can once again get validation that it is in fact a timestamp. So Pandas has automatically generated for me a datetime index consisting of valid timestamp objects, and it's all ready to go in becoming something like the index of my series or my data frame. So let's explore a couple more uses of this method. So I'm going to copy this code right here and just execute what we have now. So as I mentioned, this frequency parameter at the end is actually pretty critical because it specifies the interval between how it's going to separate the values that make up my datetime index. So D is basically 1 day. In fact, I can put a 1 in front of here to separate or to indicate more specifically that I mean 1 day, and it's going to start and proceed towards the end in increments of 1 day. If I replace this 1 with something like 2, predictably what it's going to do is start still at the 1st of January and proceed towards the 10th in increments of 2 days. Now you may notice here we're going to end at the 9th instead of the 10th, and you may be wondering why that is, and the answer is because it's proceeding in increments of 2 days, so 2 days after the 9th would be the 11th, and that's already crossing over the end boundary, so it's not included. So here we're going to have a 5-item datetime index instead of a 10-item because we're proceeding by 2 days. And there are a bunch of different options that we can put in for this frequency parameter to modify how the dates are generated. For example, we have a capital B, which basically means business days instead of regular days. So predictably, because this option is going to exclude weekends, we're going to get only the business days, and that's going to lead to a shorter list. So for example, we can tell here because it's starting at the 1st and it's skipping the 2nd and the 3rd, we can automatically tell that the 1st is a Friday and we're picking up here on the 4th on a Monday. Then we have a Tuesday, a Wednesday, a Thursday and a Friday on the 8th, and the Saturday and Sunday make up the 9th and 10th. So because those are weekends, those are not going to be included, and then we're finally ending at the end date, which is our January 10th. Let's expand this now to, let's say, the 15th and show you some additional options that are available for frequency. So one option that we have is W, which is short for week. So this is basically going to include 1 day per week, and you can see here that it's actually defaulted this W to mean W Sun, which is short for Sunday. So if I look at this date, you might be wondering again, why is it showing me January 3rd even though I specified the start as January 1st? Well, the answer is because it's starting at the 1st, but it's looking at days that are only falling on a Sunday. So the 1st is a Friday, so the 2nd is a Saturday, and the 3rd is the first Sunday that falls within my date range. So it's including the 3rd. It's moving forward 1 week to the next Sunday at the 10th, and those are the two values that are going to be included. The following Sunday, which is the 17th, is not going to be falling within our time range, so it's not going to be included. So what I can do here, if I wanted to include, let's say, the 1st, is I can change this from W to writing W dash and putting in the day of the week that I'd like to consider as the start. So I know that January 1st now falls on a Friday, so what I can do is do WFRY, which is start the week on a Friday. And you can see this time the 1st is going to be included because it is a Friday. The 8th is going to be included because it is a Friday. 1 week after that is the 15th, which is also going to be included because it falls within our date range. And then after that, we finally extended past the last boundary, and we can no longer include those values. Similarly, there are even more ways that we can get nittier and grittier here. So we have a frequency option called H, which is a capital H, and it stands for hour. And that's going to give us every single hour between the start of January 1st, 2016 and the start of January 15th, 2016. So you can see here we're starting on the 1st at midnight, proceeding to 1 a.m., then 2 a.m., then 3 a.m., and all the way forward. And similarly, just like we did with days a couple of minutes ago, we can specify a number in front of here. So if we wanted to create these date time values in increments of 6 hours between a start of January 1st and an end of January 15th, we can do something like this. And you can see it's going to proceed in increments of 6 hours. So we have midnight, then we go to 6 a.m., then noon, then 6 p.m., and then back to the next day. We also have an option here that's M, which is a little bit confusing here, but it basically means month end. So what it's basically going to do here is return the month ends that fall within my date range. And in this case, it's actually going to result in an empty frame because there are no month ends that fall between January 1st, 2016 and January 15th, 2016. But if I expand this to something like 12/31, which is the end of the year, we can see here that it's going to look between those ranges and give me the last day of each month that is still falling within my date range. So obviously January 31st, February 29th, March 31st, all the way up to the end of our date range, which is December 31st, 2016. The complementary method to M, which is the month end, is MS, which stands for month start. So what that's going to do is once again look within my date range and give me all of the days within that date range that satisfy the condition of falling on the first day of each month. So you can see here that we have January 1st, 2016, and then the start of each month all the way up until the end of our date range, which is 12/31, 2016. Keep in mind, of course, that even if we do a minor change, like changing this to the next day, like the first day of January 2017, that gives us an additional value that we can include. You can see here we're ending right now on 12/01, and now we're going to include the January 1st, 2017, because that extension of the date range gives us one more option that we can pack in there. It's one more month start that falls between our date range. And finally, just one more additional argument. Let's extend this date range now to be a couple years in the future. Let's do January 1st, 2050. We have an A argument here, which is basically short for the year end. So if you want to do that, that's going to give you a date time index that's basically going to store the last day of each year. So again, fitting the criteria of falling between the start date and the end date that we specify as those parameters. So as you can see, there's a lot to play around with here. There's a lot to memorize here, but basically the core crux of this remains the same. You specify a start point, which is the date that you want to begin. You specify the end point, which is where you want to conclude the date time index, and that date will also be inclusive, so it's going to go up to and include that day. And then the critical frequency parameter specifies the intervals or the frequencies that are going to be used to separate each point within the resulting date time index. So how much distance is there going to be between every value within my datetime index. How many days, how many business days, how many hours, how many months. And it's going to return that datetime index for you, and basically you can then use it to plop into something like a series or a data frame. So that is a very quick introduction to the date range method, and if you still need a little bit more practice, don't worry. The next 2 lessons will dive into some of the different ways that we can manipulate the parameters here to get a differently generated datetime index. So there's still plenty of practice to go with this method, so I look forward to seeing you in the very next lesson.